Hi, hello everyone. This is Fourier here. Today we are going to discuss about a very important concept in engineering, that is Fourier series. So before we move on to the Fourier series expansion, what is the importance of Fourier series and why it is used in mathematics? Why it is very important in mathematics? We have to just briefly discuss. The first thing we should know, in the name itself it is there Fourier series. That means it is series expansion. We already came to know, we already know some series expansions like Taylor series expansion, Taylor's, then Maclaurin series expansion. All those expansions we have done in previous classes. So in Taylor series expansion, what happens? The resultant series expansion, it is in terms of the polynomials. But what happens in some of the engineering applications, we may require our series expansion in the form of trigonometric terms also. For that is the reason we may not able to get the series expansion in terms of trigonometric terms using Taylor's and Maclaurin's. We are taking use of the Fourier series expansion. It's better proper approach to get the trigonometric expansion. Now, what exactly is the Fourier series? Before that, we should know some basic concepts. The first important concept is called periodic function. Periodic function. So, what is periodic function? It is the very important prerequisite for the Fourier series expansion. Periodic function means we all know that sine function is a periodic, cos function is a periodic. Why they are called periodic? Because they are in the periodic nature. Then what exactly periodic? Suppose I have a function f of x and this function is defined at some particular time interval, then I am getting same function after the time interval also, then that is called periodic function of the period t. For example, if we consider sin x, so what happens? Sin x is usually called periodic function of the period 2 pi. For example, if you consider the values of sin 0 is 0, sin 90 is 1, sin 180 is 0, sin 270 minus 1, sin 360 again 0. So if I draw this, it will become this way. After any values of sin, if you take, this complete cycle repeats. This complete cycle repeats. So that is the reason sin x is also called periodic function of the period 0 to 2 pi. In the same way, if I consider cos x is also periodic nature. Cos 0, 1, cos 90, 0, cos 180, minus 1, cos 270, 0, again cos 360, 1. So if I draw again, if you take any value for after 360, the same cycle will repeat. That is the reason sin x and cos x are called periodic functions of the period 0 to 2 pi. Now, Fourier series is such concept which is completely deals with periodic functions. Completely deals with periodic function. As I told, periodic function means a function which repeats itself after some time interval. Okay? For example, sin x, cos x and constant also we can consider as a periodic function. Now, I go to the Fourier series definition. I will consider terms called sin x, cos x, then some constant. Okay, k is nothing but constant. Now what I will do, I write the linear combination of all these terms. So in the form of f of x equal to, let it be k plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. You can see here the linear combination of the periodic functions is again a periodic function. That is very much clear. Okay. So instead of writing k, I will take this value as a naught by 2. I will take this value as a naught by 2. Now this is the linear combination of the periodic functions cos nx, sin nx and a0 by 2 constant. Here these a0, an, bn, they are all constants to be determined. Now it is a linear combination of periodic function, definitely it is also periodic. Now if I want to say this periodic function or this trigonometric function is said to be Fourier series, only it should satisfy some standard conditions. That conditions are called Dirichlet's conditions. That conditions are called Dirichlet's conditions. So what are those conditions? What it says, the first important point, the function, this function f of x is single valued function, single valued and finite in the interval 0 to, or you take the arbitrary time interval c to c plus 2 pi, c to c plus 2 pi. So f of x should be single valued and it should be finite in the interval c to c plus 2 pi. Second important point is f of x is periodic function of the period 2 pi. Periodic function of the period 2 pi. Periodic function of the period 2 pi. Third important term or third important Dirichlet condition is the function f of x have, or the function should have, f of x have finite number of discontinuities, finite number of discontinuities. So I know what is discontinuous function, what is continuous function. Any function, if I draw on the curve, if it has a break, it is discontinuous. If it is without a break, that is continuous. Okay. So this f of x should have a finite number of discontinuities in it. And the last one is f of x has finite number of maxima. Finite number of maximas and minimas. Finite number of maximas, minimas. In common word, if we take the maximum value of the function, minimum value of the function, up and downs. So these four conditions are called Dirichlet conditions. And if any trigonometric function in this form, if it satisfies these four conditions, then we can say that this trigonometric function is nothing but Fourier series function, or it is also called Fourier series. I hope it is clear. Okay, Fourier series is nothing but it's a trigonometric function. It satisfies four Dirichlet conditions, that is, function should be single valued and it should be finite in the given interval. Function should be periodic of the period 2 pi. The function should have finite number of discontinuities and the function should have finite number of maximas and minimas. So if these four conditions are whole squared, then we can easily say that this f of x is nothing but Fourier series. Now I move on to the mathematical definition of Fourier series. So again, it is very important. So what exactly the mathematical definition of Fourier series? We have a simple function, trigonometric function f of x. It is defined in the interval, f of x is defined in the interval c comma c plus 2l. I am considering arbitrary period here. C comma c plus 12 is nothing but arbitrary period. I am considering arbitrary period. Now, f of x is defined in the interval c comma c plus 2l. We have the series expansion in this form. F of x equal to a0 by 2 summation n equal to 1 to infinity a n cos n pi x by l summation n equal to 1 to infinity bn sin n pi x by l. Okay, so here I started with 1 to infinity because its previous term I have already written a naught by 2. Okay, now these a naught, a n, b n, they are all called Fourier coefficients and you have to determine them. Okay, so now we have to determine these Fourier coefficients using a set of formulae. That is a naught, what it says, a naught equal to 1 by L integral c to c plus 2L f of x dx. Then we have formula for an. An is nothing but 1 by L integral c to c plus 2L f of x cos n pi x by L into dx. Then we have Bn, that is 1 by L integral c to c plus 2L f of x sin n pi x by L into dx. These formulae are referred as Euler's formulae. They are called Euler's formulae to determine Fourier coefficients a naught, a n, b n. So this whole term is nothing but Fourier series and its constants. So very simple. The only thing it requires is basic integration concepts. If we know basic integration, then this Fourier series expansion is very simple, very easy. Okay, so in the next class we will move on to the problematic part of the Fourier series. For that, as I told, the prerequisite is integration. We should know what is integration by parts. Okay, how to integrate definite integrals, how to integrate indefinite integrals, everything we should know. We know integration by parts. Integration by parts is nothing but u into v dx is nothing but u integral v dx minus u dash double integral v dx into dx. This is normal our 12th standard method. Here u and u dash. So u dash is nothing but derivative of u, v and another function, that is v. So here what happens, this formula is mainly used for simple functions like x into sin x or maximum x square into sin x. But if we come across x power 6, x power 5, x power something more than 3, then this becomes very tedious. Okay, it is possible but it takes unnecessary lot of time. To avoid that, we will come across integration by parts general method, that is called Bernoulli's rule. What it says, u into v dx equal to u integral v dx minus u dash double integral v dx dx plus u double dash triple integral v dx dx plus or minus etc. This is called integration by parts general method or Bernoulli's rule for integration. So if we know this, then the Fourier series integration is very simple. So that is the reason I am just giving the example, rule for this. So based on this, we are going to solve some important problems on Fourier series. In the next session, we will start that Fourier series expansion problems with respect to standard problems. Okay, I hope you guys enjoyed this session. Thank you. We'll meet in the next class. Have a good day.